Welcome, everybody. Make sure I got audio. Yes. Good morning.
Good morning. Good morning.
Today is day 5.
Yeah, last day of the workshop.
Absolutely.
We were just talking before live. It's just been here for a week.
One whole
Can't believe that it's
one whole week.
we're done. Almost
Yeah.
done.
Yeah. You leave late tonight. You're on a red eye, right?
Yeah, I am to Chicago. And
Yep.
Tom leaves this afternoon.
I have a 12:50 flight. Can't wait to get home.
To travel again.
Oh no! Next week is next week. Next week is Denver. I can be coming out this weekend.
I'll be in Orlando.
Excellent. So this week, let's talk about some papers that I know I found some highlights from the week. I'll tell you my highlights.
I heard about this guy, Motrovich. He did a really good job presenting yesterday. I don't think I've met him yet. I'm trying to get a hold of him. But
We did our paper yesterday on AFCIs.
He did a good job.
He did a great job too. We went over arc fault circuit interrupters. We talked. The challenge that we had yesterday was we have 2 papers. Right, we have 2 papers. We did part 2, which wasn't the challenge. We did part 2, which was more of the science, more of the how things operate and function, and then we did part 1 as a
theory of
poster board.
operation and applications. The title was right. So
Yeah.
I guess we can back up a little bit because this was my idea, and there was a reason.
Yep.
I don't know if you know, when we started the poster session, Eva came to me. Eva Clark, she runs the poster session. She's one of the organizers of the workshop, and she's like, "What's the difference between this paper and the one just presented? They look the same to me." I said, okay, here's the history. We, 3 years ago, 2020 in Reno, Tom and I talked about GFCIs. And then we were thinking of a future projects, like let's do AFCIs. So more like the complementary thing. And said, okay, let's do it. We start working on the paper. And of course, everyone knows for 2021, everyone knows, probably remembers what happened. We went on a complete shutdown because of COVID. The Electric Safety Committee decided that safety doesn't take time off, and we should be safety conscientious all year round, so they did the virtual. But Tom and I, we enjoy the dynamics of presenting in person, so we decided to put it off for 1 year, thinking that, by 2022, COVID will be gone. Comes 2022, you may remember the Omicron wave. I couldn't travel because of the border. You guys had you were the chair last year in Jacksonville. Tom chaired the Electric Safety Workshop, and we were there, but we didn't present the paper. So we pushed it to this year. The problem is, as we were working on a paper, because AFCI, there's a lot of information, the paper kept getting bigger and bigger and bigger. And there's a page count limit.
Because we had so part 1 is more
history. But this was pre-part 1, right? Like the paper was like 16 pages. So the total, the limit is like 8, 9, 10. You can get away with 10, but it's just massive. Like I end up with 16 pages. Like we can't do this as one paper. And this is the idea that's how the idea of part 1 and part 2 came into existence. So we decided that all the history stuff, all the, background information that you need, like the wiring methods or material that used in house, like NMB and SPT, which is not related to AFCIs. But it's important to know what they mean when you're testing, like learning what UL, the history, why did we have, if all the stuff was part 1. And then part 2 was, Tom was just saying, the theory, detection, theory of operation, how to detect an arc fault, and so forth. Success stories, we shared some successful stories of how AFCIs kind of saved the day for some people. What else? Installation requirements, the NEC and the Canadian Electric Code in US and Canada. Technology is available.
Yep.
Circuit breakers, AFCI circuit breakers, AFCI receptacles. So the paper is technical, very neutral. We're not telling you which technology to use or implement. It's like, this is what's out there. And this is the information that we believe, Tom and I, that the reader would need to make an educated decision. Yep. But we don't tell you which is better, because they're all, it's just like, we were talking about this in the presentation, like an ecosystem. They all exist, like all different types, all the different means of protection exist, and they work together. At the end of the day, our goal is to make sure that we don't have any residential fires, which is the reason that AFCIs came into existence, and again, we covered that in part 1.
Yep.
The challenge was We didn't need an hour and a half to present both papers, but the organizing committee said we can't, every paper published must be presented, and we don't want you to be talking for an hour and a half.
You're right. So what he was saying is, we have to talk about each individual paper. You can't
Right.
just talk about one and then try to publish the two. So, hey, Willie Snyder's online. Hey, Willie.
Good morning.
Good morning from Denver. Hey, I'm going to be out in your area next
We
week.
are in Reno.
So,
Oh, yeah, we're in Denver.
yeah, he's in Denver.
Oh, sorry, I thought you said good morning from Denver.
No,
You-
no, I
oh,
was reading his notes.
My
It says, hey, Tom D, Niha, good morning from Denver.
Because you just said you were going to Denver next week. We're still in Reno, Tom.
Right. Yeah, he's in Denver. So, Willie, I'll probably see you next week.
Denver's a nice
I'll let
city.
you know where I'm at. So, in any case, all right. So let's talk. So,
So I
other
guess
things.
just to finish the conversation, so we end up having two parts.
Remember where we're
Part
at.
two, we're talking part one, part two. So there's another option of presenting a poster presentation. So we had a 45% oral presentation for one part and then poster for the second part. Tom and I decided that it would make more sense to talk about the theory of operations success stories as an oral presentation or a poster, but this was part one. Sorry, this was part two. So we ended up presenting part two before part one. That's why it was it was like our icebreaker. Tom did a good job and just kind of letting everyone know that you're seeing the future, I guess, or the second
Yeah. So we did part two
Yeah.
first. We did part two as a presentation, and then we did part one
As a
as a thing. So let's talk about other things.
Cool.
Yeah. So we did. So one of the items that I thought was cool, and I think you noticed it as well, is did you really test? Not did you really test that interlock? It was using the proximity
Oh yeah,
voltage
it was
sensors.
the first day. It's like why it's not appropriate. You shouldn't use the proximity sensor or voltage tester for the absence of voltage test, right? Joe Rashford, I believe.
Yeah,
was
scientist
presented on-
perspective, proximity,
Use
there
the-
it is.
yeah, proximity.
Why can't a person use a proximity sensor to verify a zero voltage state
Right.
for low voltage systems? So these are those items that sort of look like this. All right, so that's what they look like. And he did I think an awesome job of explaining all of the details that are important to make sure that these devices function correctly.
Joe is a veteran, and I always enjoyed, over the years, enjoyed his presentations.
Yeah.
They're very simple. Like he doesn't clutter his slides with too much text,
That's exactly
He
right.
just talks to the audience. It's not reading off his slides and so forth. Yeah. So I enjoyed his presentation.
Yeah.
This one and the previous ones too.
Yeah, and then the other, what was the other item?
You like our friend from Finland presentation, right?
Yeah, I did enjoy the Finland presentation.
So
All right.
we have our chair, Mark Scott, who's just moving.
And
Everybody's saying hi, Mark.
yeah, everybody's saying, "Hi, why don't you come?"
Come say hi.
They're closing out the system.
I'll just move over. I guess we can.
Yeah, like the camera's over there. There he is.
We have-
the man. He's going to close out
I thought you were gonna have a seat
close
with
out
us.
the week this week. So good week, right?
Good job, Mark. It's like you did a lot of
When
work.
do you fly out?
Thank you.
Oh,
was
okay.
driving,
You drive
yeah,
out tomorrow.
California.
Well, cool. Great job this week. All right. So the other paper that I really enjoyed was the one that was talking about the fact that your your risk evaluation changes throughout the job
Situation, yeah.
based upon the situation.
I remember that one, yeah.
And then that really intrigued me in that you can be performing a project. You can have your safety talk before you start your work. You can do all of your details, what tools you're going to bring on the site, all of that good stuff. And if things change while you're working on the equipment, conditions could change. Not even electrical conditions. There could be environmental conditions that are changing around you,
Stress.
right? Yeah, and the stress, fatigue,
right?
just the individual's perspective. So how do you adjust and realize that your risk evaluation is a continuous process.
Right, and educating the worker that, you know what, when you get to that state, you have to take a step back and say,
Yeah.
I have to stop now. Like, don't try to, I'm going to push through for another half hour, and I'm going to get it done. Or my boss is going to be mad at me, or supervisor will be mad at me because I didn't finish the job. This is really important. It all goes back to culture. I don't know if you were in. Did you watch Mike Doty's presentation, the leading and lagging indicators for safety? Because he's talking about all this stuff. Like Mike Doty, it was presented yesterday.
I think I was there.
Yeah, because Mike always talks about those soft skills, cultural shift. Hey, when I did a paper last year virtually on human performance tools and the effect of human performance on electric safety and the human performance tools available to help mitigate errors, because humans, you can't eliminate human error.
Right,
You can try to address it because we err.
Yeah, there it is. The deeper dive into leading, lagging indicators for electrical safety.
Yeah, the one.
Yeah, yeah, and then we had the 347 600 volt arc flash mitigation at British Columbia Hydro.
Yeah.
That was pretty good.
Fellow Canadians.
Yeah, fellow Canadians. And I wasn't there for the 70B discussion, but from Carl Cunningham and Marcella.
I missed that one too.
Yeah.
I think we're working on our presentation or
I
something.
think we were. We were going over our PowerPoint and making sure we had our ducks in a row. But this one, 70, and I'm on 70B, so I kind of know what they should have been talking about. But it's great that on a workshop like this, that it really shows that you're not just focused on 70E. You had discussions about the code.
Yeah.
You had discussions about 70E, and you have discussions about 70B, the three key parts of electrical safety.
And Tom, to your point, last night Tom and I went to dinner with Bill Harris.
Yes.
He's working for a construction company, but his career was with General Motors. Like, he's a big
and there was
maintenance safety of General Motors. He had a lot of great stories, but the one thing, to your point, when I think you were telling stories about talking to very highly educated individuals, and they talk about, okay, show me your safety plan, and they have it, and then you talk about the maintenance plan and stuff. What are you talking about? So unfortunately, a lot of people out there, they don't know that safety and maintenance go hand in hand, and you're talking about taking pictures and showing the team that,
There's a lot of opportunity when you have facilities. If you can have somebody who's very keyed in on electrical safety and 70E.
Right.
And they have a great safety plan, but then when you start asking the questions about, okay, what's the maintenance plan, and then there's the stare, right? And you say, well, and I think a lot of us, just in a lot of our industry. When I say us or I say we, I'm really talking about the industry.
Yeah.
When the industry, if you look at various companies or various individuals, always down to an individual, you could say, you're a very safe driver, right? You can say, look, you're a really safe driver, but when was the last time you had your car looked at from the brakes perspective, or the oil and are you performing maintenance on your vehicle, which is propelling you down the road at 80 mile an hour sometimes, or depending upon who you are, it could be a lot faster.
Of course.
Right? So, but maintenance seems to not be a topic of discussion.
It takes a back seat.
It does take a back seat.
It's oftentimes, which hopefully this will change soon, since now 70B is a standard, not a recommended practice. Maybe this was part of the stigma. It's like recommended practice. It's still a standard, but it's more like you could do this, you may do this. It doesn't have the language of shall, should,
Right,
shall, not the should, the shall language.
Yeah, so we had, the other one, the doors wide open, safety beyond the standards. That was an interesting presentation, looking at the arc flash equipment.
Oh, this is the Finnish, our friend from Finland, right?
No.
I can't remember.
No, this was John Kay.
Yeah, sure. Yeah, it was one because John Kay he couldn't make it. John Kay is a good friend of ours, Canadian too.
Mikko Maninen. So you're saying they're from Finland?
Yeah.
Oh yeah, that is. Yeah, that is Finland.
I know Joe. He's like a good friend of mine.
That's
I
right.
met him
Yeah.
through PCIC.
I was thinking of the other gentleman.
Okay, yeah. So, so I thought you because these guys are from.
I
Finland.
didn't even realize. I never even looked at where they were from.
So we're talking about like two Finnish gentlemen, but thirdly, Tom and I were two different people.
There's another individual who's.
The one who stood up at the mic and asked the question.
Yes.
Okay, now I know what
he
you're
had
talking about.
some really good thoughts.
And we had good questions too.
Yes, he did. Yes. Comparison. So they did comparison of arc flash, of arc containment and mitigation techniques. They talked about arc resistant switchgear, remote control operation fuses, current limiting circuit breakers, all these different things. So I think one of the key takeaways that I had from that, what was going on in my mind while I'm listening to this paper about working on equipment, like arc resistant equipment versus equipment, because arc resistant equipment is only arc resistant when the doors are closed, right? So the moment an electrical worker exposes themselves by trying to take voltage measurements, now you don't have the value of an arc resistant piece of equipment. So he went through all these different solutions, and I think that, and I think even in one of Marcelo's discussions as well, there's that continuous observation that the overcurrent protective device provides that method to reduce the clearing time, which reduces incident energy. So the strategic placement of an overcurrent protective device is critical to addressing the second part of risk, which is severity, right? So if you're going to do voltage measurements and things of that nature, knowing where your overcurrent protective device is, whether you're relying on the one that's in the equipment, which you can't, right? You have to go to the next upstream device. Where is that upstream device? What is that upstream device? Yeah. What is your available fault current? How long it will take to clear the fault? So there's a lot to be said about. There's a lot to be said about understanding all of these different technologies, and he didn't say it, and I was going to go up to the mic, but I didn't, because what I don't like is when somebody goes to the mic with a statement instead of a question. Not a question, yeah. Because you can make your statements elsewhere. But what I was going to say was that I call it the zone of protection, right? Zone selective interlocking, that's in 24087 or in 24087. Your protection is only between your upstream device and the zone selectively interlocked downstream device. If you have a fault on the line side of that or on the load side of that downstream device, then you're outside of the zone of protection. You don't get the value of the technology. Differential relaying, same way. You have a zone of protection, and he included that in his paper. He talks about a bus differential scheme. He talks about zone selective interlocking requires more sophisticated relaying and application practices. So he was defining the zone of protection without actually saying the zone of protection. Right. You know,
which is kind of interesting, because I remember when I went to school, electrical engineering, power. I guess my power and machines major. As you remember, Tom, the curriculum is heavier or more based on utility practice. It's not industrial, right? And on the utility side, it's very, very. There's something funny. We have to share to them.
He says, Arc Flash Friday has a good ring to it. It does. Arc Flash Friday.
Boom, 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 boom. It's a boom. Yeah. Yes. So, we said this at the end of the presentation. It's arc fault circuit interrupter, not arc flash circuit interrupter.
Yeah, but what we're talking about now is arc flash.
Exactly.
Yeah, it had nothing to do with our paper. Yeah.
So, I guess I don't know why I remember our paper. Anyway.
No, but you're right. There is a difference. So we made that distinction in our paper. We talked about that it's an arc fault circuit interrupter. Yeah. Now, we could have made the argument that it is an arc flash, but it's a really, 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 really small arc flash.
We said lower energy.
We said that in our discussions. I did not say that on the stage. I could have, and I probably should have.
I thought you did.
I don't think so.
I think you did, but anyways, I think, because we talked about the 120, and then you talked about the 5 amp and 75 amp, the threshold, turf threshold, so forth. But back to that, we were talking about the.
We're talking about the different types of techniques and the zone of protection.
Right, yeah. So in school and university, when you study this, they talk about backup protection and primary protection, and that's like utility practices, because the investment is really high. And I remember, this was drilled into my mind when I was in I always confuse the terminology. Like a sophomore.
Are you always confused?
Junior, the terminology at college in the U.S. You have senior, like you have senior year, sophomore, junior.
Oh,
so
the
I'm
hierarchy of
Yeah,
going,
I was trying to remember
you
which
go through
year.
high school, you go through college, and then
But then within college, like your first year is your
freshman,
freshman, and then a
sophomore, junior,
junior,
senior.
So my junior year, juniors, yeah,
Third year.
third. This is what I'm trying to translate.
I usually just say third year because
Yeah, 'cause I wrote of my first act my junior year. Which year was this? Anyway, so my third, fourth year, I just drilled in my brain that your zone of protection it's like a border, and it's determined by your current transformer. So you have current transformer here. There we talk about differential, bus protection, any kind of differential scheme or whatever distance rating, anything that you're using. You can tell that these are the boundaries, the current that you're measuring or voltage, and in between you're protected. But once you're out of this, to your comment, Tom, out of the zone of protection, you're not protected.
Right.
You have to be, yeah. So, and what the practice in utilities is you to overlap your zones of protection.
Correct.
So that you don't because you don't want to end up with a dead spot. Like if there's one zone here, one zone there, what's in the middle?
So that's a difference. So in like relaying in the utility world, like when I worked with a few utilities on relay protection, like distance relays and differential, things like that. You're right. They overlap the zones of protection. Now, when we get to low voltage equipment, it's hard. It's hard. It's easy. It is actually relatively easy, and the technologies exist to maintain that practice that you see in utilities on medium and high voltage applications. In low voltage applications, it's easy to do. It's hard to pay for, right?
It's not justified.
So we have a lot of relays. We have sensors. You could apply the same relays that you have, or a lot of the same relays that you have on those other systems to these low voltage systems. But it's just not. It's just not economically feasible.
Because again, when I start talking, the investment. The assets that the utilities invest in, like all the transmission lines, their assets, is very expensive. So they want to make sure that they're protected. It's like
it's relatively cost. So
industry is not.
For example, on motors, right? So on very small motors, what do? We put a thermomagnetic circuit breaker or current limiting fuse or something, and maybe you don't even have the overload because hey, if it fails, it fails. It'll clear, and then I replace it because it's so inexpensive. And then as the size of the motor goes larger, now you have more complicated drive systems, you have more complicated protection systems. And then when you get these really large motors, now you're getting into RTDs that are embedded into the motor itself, and you bring that into a relay where it's monitoring the temperature of the motor. You're looking for negative sequence currents. You might have a negative sequence relay, right?
Yeah.
So there's a lot of different things that you'll look at on that motor, and you will put more protection because it's not a $15 motor. It's a,
Right. No.
it's a $18,000 motor or a $50,000 motor or even higher.
It's like it's like the mansion that Tom's mansion in
The mansion? Oh, my house.
Yeah,
It's not a mansion.
No, this is what I heard.
Yeah.
It's in West by God, Virginia, right?
Yeah.
It's like you have to invest to make sure that keeps up. But the shack living in Canada, it's just
My shack in Canada. Yeah. So depending upon the infrastructure, and now for like differential relaying is a great technology. What I like about differential relaying is that the current sensors are on the line side. So you have the conductors coming into the main breaker in an enclosure,
Right.
and you'll put your CTs on the line side of the lugs, the terminations. So if I have a fault on the terminations of my primary overcurrent device, my sensors will detect it because it is encompassing the line side lugs. Zone selective interlocking, which is built into the circuit breaker, only looks at the secondary lugs and the primary lugs of the downstream breaker, right? So it's not picking the line side and the load side of the line side of the upstream and the load side of the downstream. So, because those are out of the zone of protection. So, but I'm not going to put I'm not going to put differential relaying in some of these low voltage switchboards.
It's too expensive.
It's
not
just too expensive.
justified.
Yeah, because you need a separate relay, you need all that wiring internal. So, but in any case,
In theory, I guess my point is, like Tom agreed with, in theory, we can do that, but then you'll end up spending maybe 10 times more
Right.
on the system, the cost of your system, which doesn't make sense.
right. So then, what do we go through in our head when we make these types of decisions, we're going through a risk analysis, right? So we're going to say, look, I'm not going to spend X amount of dollars to put this technology in this equipment that will be so inclusive. What I'm going to do is I'm going to put this other technology, and I know there is a likelihood that I could have a fault at these locations and not be protected. But what is the likelihood of that? And I'm not using it for personnel protection, right?
Yeah.
Because I can't take advantage of that for personnel protection.
Yeah, motors are more tolerant. And I believe, as was mentioned during Mike Doherty's presentation and someone else, maybe Lenny, residual risk. I think that's what you're referring to. Like you just do your assessment, and it's kind of more of what kind of risk, residual risk I can live with, because you can, I guess.
No, I might do other things. I might say, I'm going to put a barrier on the line side of my
lower your
overcurrent device.
risk, right.
So I'm reducing the likelihood. I'm not reducing severity whatsoever, but I'm reducing the likelihood that someone's going to accidentally come in contact with it, which could cause an arc flash event. So we can take approaches, and I heard somebody reference it, I believe it was on stage, as the layers of the onion, right? I'm adding layers to this onion of safety, so that I'm reducing and trying to managing my risk. All right, we got Robert from Omaha. We've got...
we have good crowd this morning.
Yeah, good morning, Tom. Robert from Omaha Green. Thanks for what you do for electrical safety. Have you been reminded of the great work you do? Oh my gosh, Robert, you're hilarious.
Yeah, and this is kind of nice, I guess, because this is for the first time we're sitting down, so we can see the comments.
Yeah.
Last 4 days we were standing away, so we often, we didn't mean to ignore any comments, but just we couldn't see them because the laptop was just too far.
Yeah, exactly. And I have a hard stop at 7 a.m. Pacific, so we got 6 minutes, and I have to get on a phone call. So, but in any case, so that was a really good paper. Now let's talk real quick about next year's.
Yeah, so next year, the workshop will be held in Tucson, Arizona. Should be really nice weather. During the presentation, we talked about the golfing opportunities and hiking, and coming from Canada, a week in Arizona is not a bad thing. It's actually enjoyable.
And the program is still open, so if you have ideas on papers that you want to write and things that you might want to do, then...
May 19th is the deadline, so you have till May 19th, and on the website there's under participate, there's like you go to the drop-down menu or top menu, it says call for proposals, and by proposals we mean you can submit a paper for 45 minutes presentation, a poster presentation like Tom and I mentioned, the poster, or you can submit what they call a case history, which is usually like a 15-minute presentation. That's not 45 minutes, and this is simply, we had maybe this problem or whatever, this is how we solve that problem.
You can do a case study.
A case study or case history.
Yeah, and you can do, so if you go to Electrical Safety Workshop, all one word, .com, go to the menu item called Participate. You click on Participate, you'll see the very first option is Call for Proposals, and then you can submit a proposal online. The papers will go to Dennis Hill, Terry Perillo, and they'll give you some information on
So Terry for the
topics.
tutorials, by the way. Sorry to interrupt. Terry for the tutorial, not for the paper. And you can submit a tutorial as well.
Very good, very good. You have topics for your paper. They give you some ideas. They'll give you the presentation formats, the full length, the incident case histories are generally 15. So that's what Neil was just talking about. Then they talk about the poster presentations as well, and paper publications. You don't need to be an electrical engineer. You don't need to be an IEEE member, right?
Yeah.
You can submit.
You just
your
need to be
idea.
passionate about safety. That's all you need.
Absolutely, you need to be
Just
passionate about safety.
And all you need at this stage is an idea, an abstract. So I guess we need to make it clear that you're not required to submit a full paper at this point in time.
Absolutely.
It's just that abstract, an idea, and then there's a technical committee, a group of very capable technical people that from the Electrical Safety Workshop, they will evaluate all the proposals, abstracts, and then if your idea is selected, then you get a nice email saying, congratulations, now you can start writing your paper. I personally, Tom and I, and this is kind of what we like, I start working on my paper before submitting the proposal just because things get, busy and whatever. But this doesn't mean, if you're efficient, I'm not as an efficient writer, it takes me longer time than the average person. But if you're an efficient writer that can maybe crack a paper in a week or two, all you need now is just an idea, just a
Yep.
simple idea, abstract, when it's accepted. And of course, you don't need to have all your authors lined up. It could be just you, let's say,
That's right.
I'll be doing a paper maybe with Tom, and then you're looking for a co-author from industry or from utility or whatever, right? So I guess my point is, at this point in time, you don't need to be like ready 100%.
Yep, yeah. So if you have an idea for a paper, go out there to Electrical Safety Workshop. And if you want to help you need a mentor in that regard, both Nihad and I are willing to mentor you in helping develop a paper. And maybe we aren't a co-author, maybe we know somebody else that you could pair up with. That might be interested in helping you with your paper. Like if you have something on PPE, we might know somebody in that world that makes clothing that might find your ideas and your concepts attractive, and we can marry you up so that you can present together or develop a paper together, and you'll learn in that process. All right, so it is, what time is it? It is
You have 2 minutes,
6:58, so I need to go. So, all right, so we talked about the future. We talked about some of the key things that happened this week. Hopefully I will see you, and Nihad and I will see you in Tucson, Arizona next year.
Yeah, it would be great. And if everyone out there hearing us, just consider attending. I guarantee you won't regret it. It's a great experience.
And again, you don't need to be an electrical engineer. You don't need to be an engineer, period. You just need to be passionate about electrical safety. And you can take something away from these events. So look forward to seeing you in
I don't know if we
Tucson,
said that,
Arizona.
but you can also bring your significant other.
Yes,
So this is another thing. It's nice city, like nice time, nice weather. So yeah, if you want to make this even a work/pleasure trip, you can do that. A lot of people do that. So another thing to add.
All right, everybody. Thanks for joining in. Thanks for what you do for electrical safety.
This concludes our reporting week from Reno.
It does. It concludes our reporting week from Reno. Thanks, Robert. And Willie, thank you for joining in. Appreciate you and your program as well. I know you just said you did a program earlier, so check out Willie's channel as well.
And
be a mentor and not a tormentor.
Yeah, torment. And safe travel to you, Tom. I know. Hopefully, I'll see you before you leave. I know you're busy with calls, so I will.
Yeah,
if I don't see you,
we'll definitely see you.
Yeah.
Safe travel.
Thank you.
All right, buddy. Take care. Stay safe.
Thank you, everyone.
Please
stay healthy.
Stay healthy. All right. Take care.